Hey kids, welcome to section 6.5, properties of logarithms. Today we're going to learn how to simplify and evaluate expressions using the properties of logarithms and how to solve logarithmic equations using the properties. So, because logarithms are exponents, the properties of logarithms can be derived from the properties of exponents. So here are three properties of logarithms. The first property is called the product property, and that's when you're multiplying log base x of a times b. The rule says that you do log base x of a plus log base x of b. The quotient property of logarithms says that when you are dividing two logarithms, log base x of a over b, that you take log base x of a and subtract log base x of b. Finally, the power property of logarithms says that if you have log base b of m to the p, that you can take the power p and bring it down as a multiplication in front. So those are the properties that we're going to be using throughout the section. Example number 1, given log base 3 of 2 is approximately 0.631 and log base 3 of 7 is approximately 1.2091, approximate the value of each expression. Okay, so first we have log base 3 of 14. Well, I need to rewrite 14 in terms of 2's and 7's, and 2 times 7 is 14. So we're going to rewrite this as log base 3 of 2 times 7. Then if we use the product property of logarithms, it says that when you multiply something, you're going to add their logs. So this is log base 3 of 2 plus log base 3 of 7. So now I substitute what log base 3 of 2 is, which is 0.631, and I substitute in what log base 3 of 7 is, which is 1.2091, and I add them together, and I get 1.8401. So we're taking what we know and substituting it in for the functions, or the expressions, I should say. All right, letter B, log base 3 of 49. Well, think of 49 in terms of 2's and 7's. And so we can do 7 times 7. We could do 7 to the second power. It doesn't matter. You get the same thing. So let's do log base 3 of 7 squared, because 7 squared is 49. So the power property says you take the 2 and you bring it down and multiply in front. So 2 times log base 3 of 7. So now substitute in what log base 3 of 7 is. So 2 times 1.2091. If I multiply that together, I get 8. Oh, my bad. Hold on. Okay, my bad. I get 2.4182. Okay, if we look at letter C, log base 3 of 7 halves. So when I divide two things, the properties say that I subtract. So this becomes log base 3 of 7 minus log base 3 of 2. So I find log base 3 of 7 is 1.2091. Log base 3 of 2 is 0.631. And if I subtract those, I get 0.5781. Okay, letter D, log base 3 of 0.5. I have to figure out how to get to 0.5 using 2's and 7's. Well, if I do 1 divided by 2, I get a half, which is 0.5. So I can rewrite this as log base 3 of 1/2. So then I can use the properties and do log. I can do log base 3, and 1/2 becomes 2 to the negative 1 power. So then I can use the power property, which says I bring that negative 1 in front, negative 1 times log base 3 of 2. So that's negative 1 times 0.631. And that's negative 0.631. So you have to figure out how to use what you're given to find something new. All right, so we're going to use those properties again to solve equations. So the first thing you want to do is get rid of any products in front, any coefficients. So this 2 needs to be dealt with first. And so instead of bringing the 2 in front, I'm going to put the 2 up top. So this becomes log base 7 of x squared equals log base 7, 27 plus log base 7, 3. Now I know that if I'm adding 2 individual logs together, that I can combine them by multiplying. So this becomes log base 7 of x squared equals log base 7 of 27 times 3. So I can say log base 7 of x squared equals log base 7 of 81. Now, since I have log base 7 of x squared equals log base 7 of 81, I can set the x squared equal to the 81. Then I can square root both sides and I get plus or minus 9. Now, when solving equations with logarithms, you need to make sure that if you substitute the answer back in, you're not trying to take the log of a negative number. So if my two choices are 9 or negative 9, if I were to sub my answer back in for x, if I sub in 9, I'm okay. But if I try to take the log base 2 of negative 9, you can't take the log of a negative number. So negative 9 is extraneous. That looks a little bad. And so our answer is just positive 9. If we look at letter B, looks like I have addition going on the left-hand side, so I can combine by multiplication. So log base 6 of x times x plus 5 equals 2. So I can distribute log base 6 of x squared plus 5x equals 2. And I'm going to put this in a grouping symbol. Now notice I only have a log on one side, so I need to change this into exponential form, and it'll help me solve. So I'm going to do 6 to the second power equals x squared plus 5x. Well, that's 36 equals x squared plus 5x. Notice I have a quadratic equation right now, which means I need to get everything on one side. So I'm going to minus 36 to the right. So that's 0 equals x squared plus 5x minus 36. This is a quadratic I need to try to factor. So I need to come up with two numbers that add to give me 5 and multiply to give me negative 36. So those would be negative 9 and positive 4. So then I take each of my factors, x minus 9, set it equal to 0, x plus 4, set it equal to 0. I get x equals 9 and x equals negative 4. Remember to always check it by plugging it back in. If I plug 9 in, that's positive. 9 plus 5 is 14, that's positive. 9 works. If I plug negative 4 in, I can't take the log of a negative number, so negative 4 is extraneous. All right, let's look at some more equations. These say solve. So first thing I want to do is get rid of any coefficients in front. So log base 10 of u equals log base 10 of 4 to the 3/2 power. So I can do 4 to the 3/2. Remember, 4 to the 3/2 is the square root of 4 cubed. You take the bottom number and put it on the outside. You take the top number, put it on the inside. Or you can put like that. So the square root of 4 is 2. So that's 8. So I can say log base 10 of u equals log base 10 of 8. Since they're both log base 10, I can set u equal to 8. Letter D, let's see, I've got a 2 in front I need to deal with. So log base 7 of x plus log base 7 of x squared minus log base 7 of 3 equals log base 7 of 72. Okay, they're all log base 7s. That's good. So if I'm adding these individual log 7s together, I'm really multiplying. So that becomes log base 7 of x cubed minus log base 7 of 3 equals log base 7 of 72. Now I've got two log base 7s again with subtraction, so that's division. So I can simplify by saying log base 7 of x cubed over 3 equals log base 7 of 72. Since they're both log base 7s, I can set the rest of it equal to each other. So x cubed over 3 equals 72. I can multiply both sides by 3. That gives me x cubed equals 216. Then I can cube root both sides. And the cube root of 216 is 6. All right, let's look at more equations. So again, solve. Letter E, let's see, do we have any exponents to work with? No. I've got log base 8 with addition, so that means I can multiply. So log base 8 of n minus 3 times n plus 4 is supposed to equal 1. Well, I can change it to exponential form by doing 8 to the first power equals n minus 3n plus 4. So that's 8 equals, and on the right here, I can double distribute n squared plus 4n minus 3n minus 12. I can collect like terms and bring the 8 over to the other side. So let's collect like terms. 8 equals n squared plus n minus 12 minus 8. So 0 equals n squared plus n minus 20. This is a quadratic function, so I need to try to factor. So I start my two parentheses, put my letter at the beginning. I need two numbers that add to give 1 and multiply to get negative 20. So that would be 5 and negative 4. Then set each one of them equal to 0 and solve. So this one solves by subtracting, so n equals negative 5. This one solves by adding, so n equals 4. Check and see if you plug that number in, if it makes it negative. So if I plug negative 5 in, negative 5 minus 3 is negative 8. That's a no-go. That's extraneous. If I plug 4 in, 4 minus 3 is 1. 4 plus 4 is 8. They're both positive, so my answer is n equals 4. All right, if we take a look at letter F, log base 3, log base 3, log base 3, I have addition on the left side, so I can simplify by multiplying. So log base 3 of a plus 3 times a plus 2 equals log base 3 of 6. All right, so I got log base 3's on both sides, so I can set the rest of it equal to each other. A plus 3 times a plus 2 equals 6. I can double distribute on the left. A squared plus 3a plus 2a plus 6 equals 6. I can collect like terms on the left side. A squared plus 5a plus 6 equals 6. I can move the 6 to the left. A squared plus 5a equals 0. I can factor an a out. A times the quantity a plus 5 equals 0. Two things that multiply to give me 0, set them each equal to 0. So a equals 0. A plus 5 equals 0. So a equals -5 and 0. So let's see if I plug 0 in. 0 plus 3 is 3. 0 plus 2 is 2. They're both positive, so that one's okay. If I plug in -5 plus 3, that's -2. Oh, right away it's negative. So we're going to say extraneous for the other one. All right, we got 2 word problems here. This and then the next slide. Recall that the loudness L of a sound in decibels is given by L equals 10 log base 10 of R, where R is the sound's relative intensity. If the intensity of a certain sound is doubled, how many decibels does the sound increase? Okay, so if I choose some numbers for the sound's relative intensity, let's say if R equals 10, and then we'll do it if R equals 20. So it says if the intensity is doubled. Well, it doesn't say what it starts with, so pick something that it starts with, then double it, and then we're going to compare our answers in the end. So we have L equals 10 log base 10 of 10. And over here we have L equals 10 log base 10 of 20. So over here on the left-hand side, L equals 10. And remember, when the base is the same as the bigger number, that this equals 1. So here we have L equals 10. Over here on the right side, we have L equals 10. Now 10 log base 10 of 20, we can just do log 20 because that little 10 doesn't matter. If we grab our calculator and I type it in 10 log 20, I got 13.01. So how many decibels does the sound increase? Well, it looks like it gets 13, or it looks like it gets, so it's increasing from 10 to 13.01. So if we subtract them, we can say it's about 3 decibels. All right, last question. A chemist is testing a soft drink. The pH of the solution is given by pH equals negative log base 10 H to the plus, where H plus is the concentration of hydrogen ions in moles. The pH of a popular soft drink is 2.5. If the concentration of hydrogen ions is increased by a factor of 100, what is the new pH of the solution? Okay, so what we can do is we can figure out how many hydrogen ions there are in this soft drink, and then we can increase it by a factor of 100 and figure out what the pH is. So let's take the 2.5 and go to the pH equation of H plus. It tells us that our pH is 2.5, so let's do 2.5 equals negative log base 10 of H plus. Then we need to get rid of that -1, so we can divide both sides by -1. Negative 2.5 equals log base 10 of H plus. Now you can change it to exponential by doing 10 to the negative 2.5 equals H plus. And then we can calculate what 10 to the negative 2.5 is. It's approximately 0.003. So that's how many the concentration of hydrogen ions in a soft drink. Now, if the concentration is increased by a factor of 100, so times it by 100, and that gives you 1 to 0.3, I want to know what the pH level is. So we take this and we go back to our equation and do negative log base 10 of 0.3. And if I type this into the calculator, I get 0.5. So the new pH is 0.5. All right, kids, if you have any questions, please let me know. And as always, keep calm and keep trucking.